So I hope everybody's doing good. Today we're going to go over one way to organize a set of data once we've collected it. And then we're going to do a little review of median, mean, and mode just to make sure that you all understand what each one of those is and how to calculate them. In my example today, I have collected some data from the State of Alaska Department of Fish and Game regarding the annual moose harvest in our state over 5 years. I've gone from, you can see over here in the left-hand column, I've gone from 2015 to 2019. And as you can see, I'm going to organize the data I've collected into a simple table on Excel. I know you've all been learning how to use Excel, so hopefully we can just expand on that learning. Excel really is a great tool for what we're doing here. So let's get started.
As I said before, I have the years over here, 2015 through 2019. I have the total number of permits issued that year, how many people actually hunted, because not everybody that got a general moose permit hunted. Then we have the bulls and the cows that were harvested and the total harvest. And then I'm going to also show you how to calculate the success rate of the hunters. So let's start with 2015. There were 43,529 permits issued. There were 22,482 people that actually hunted. There were a lot of bulls harvested that year, 4,792. And then there were only 173 cows. And then over here, find the total harvest. Obviously, we would just add these two numbers together. And when we do that, we get 4,965. So let's just really quickly look at how we would calculate this success rate.
In this data, you might feel like you want to take this number down here, like how many permits were issued. But that's not the number, because remember, again, not all of those people actually hunted. And in order to have a chance of success, you have to get out and hunt. So this is the number that we want. So we're going to take the total harvest and we're going to divide that by the actual people who had boots on the ground and gave it a shot. So I'm going to pull up my calculator here, and we're going to take this total harvest, like I said, so 4,965, and we're going to divide that by the number of actual hunters, 22,482, enter, and that's going to give us, this is our success rate. So we're just going to round to 2 decimal places here, so that gives us a 22% success rate.
So, now that that's done, let's talk about the mean, the median, and the mode. So the median, which is the middle value, is a measure of central tendency. It tells us what our middle value is. So, for example, I'm just going to use this space right here. The numbers that we're working with today are pretty large, but really we just want to find the middle value of our set of numbers. So in order to do that, we would put these numbers in numerical order, and then we would figure out which one was in the middle. Luckily today, we have 5 numbers, which is an odd number, which means our middle value will be right smack dab in the center. And if these were in numerical order, or in order of the value from least to greatest, let's see, this number right here, 41,455, would be our middle value. If we had an even number, I'll show you an example right here. Let's see. Let's say we had a set of data that had 2, 2, 3, 4, 5, 6. So now we have 6 values. In order to find the middle value, we would find, in this case, the 2 numbers that were in the middle. Because this is an even number, there's going to be 2 numbers in the middle. So let me pull up my calculator. And in order to find the middle value in a set that has an even number of entries, values, we're going to add these 2 in the center together. So 3 plus 4 is obviously 7, and 7 divided by 2 is 3.5. So our middle value is 3.5. So that's that. That's how you find the median. The median is your middle value, the value that's right in the center of the data. Moving on to mean. Mean means average, and averaging things is pretty easy. Alright, so in order to calculate the mean, I'm going to get my calculator here. Let's find the average of cows harvested over those 5 years. So in order to do that, I'm going to take these 5 numbers, and I'm going add them together. We have 223 plus 170 plus 169 plus 178 plus 173. And that gives us 913. So we take that total and we divide it by how many different values we have in our data. So in this case, we're talking about 5 years. So we have 5. So we're going to take this total, 913, and we're going to divide it by 5. Our mean is 182.6. Moving on to the mode. The mode is the number in the data set that occurs the most. And in this case, there's no, like if we look at the cows, for example, there is no one number that occurs more than once there. So as far as a number that occurs the most, it's kind of a tie. Everybody's tied at occurring one time. So it's really not applicable in this case. I scroll down a little farther. This is not actual data. This is just an example of what we would do to find the mode. Let's take the month of September because that is typically when the general moose season is open. And if we pretend that 32 moose were harvested on September 1st and 50 on September 2nd and so on and so forth, in order to find the mode, we would need to look and see what is the frequency of 32 moose harvested in one day. Does it happen more than once? I don't see another 32 in this set. So then we would move on. Do we see another 50? I do not. Do we see another 98? Yes, I do. I see a 98 here, and I see a 98 here, here, and here, and here. And we just go down the list and, try and keep track. It looks like, though, in this set of data, 98 moose harvested in a day occurs more frequently than any of the other numbers. Our mode, I have to scroll down here, or the number that occurs the most is 98. That is how you find the mode.
Again, median is a measure of central tendency. It is the middle value of your set of data. Mean is just simply the average, and mode is the number that occurs the most. And there you have it. Thanks for watching. Don't forget to email me if you have any questions, and we'll see you next time.